While this course focuses on the software development lifecycle or the systems development lifecycle, you can use either term, there are other methodologies and other approaches to systems development and for software development. For example, this example is from Microsoft, which shows their security development lifecycle, which is, you can see here, it's very loosely based on the software development lifecycle and the systems development lifecycle that we cover in this course, which is sort of an industry standard. So a lot of these different methodologies sort of rely on or are derivatives of the SDLC that we learned about in this course. So while you may work with an organization that might use a slightly different take or have a slightly different take on the development lifecycle than what we discuss in this course, you should be able to take what you learn in this course and apply it to many of these other models. They may not be as formal as the models that we discussed. They may have other steps depending on some of the subspecialties within the organization or even within the industry. Different industries sometimes have slightly different ways of going through this. For example, if you work in the medical field and you're FDA regulated for medical devices, there might be a slightly different approach to SDLC based on those requirements versus, say, a banking industry or financial industry, which has other regulations that you have to be cognizant of, and that might have a slightly different take on the SDLC based on that organization and that industry. So again, you should be able to take everything we talk about in this course and apply it to all of these different fields. So hopefully we give you the tools to apply this to any organization. Now, we've talked about this in the previous in my previous video that hopefully you reviewed. This design loop, this analysis and design code test loop. So we start with analysis, then we do our design, then we code, then we test, then we go back through that process. And that's that iterative process that I described before. And in this course, really, what we're concentrating on in this course is the analysis and design phases. That's the most important takeaway from this course. You can take other courses to learn project management. I'm going to cover project management to some degree. We'll have a couple units where we talk about project management and project selection and so forth, but it's not the focus of this course. You could take an entire course to discuss those topics. And likewise, you could take entire courses about implementation, which is the actual development of software. So you can take software design courses, you can take database design courses and or database development courses, I should say. You could take web development and then so forth and so on, all of those skill sets that you would need in implementation. It's important for us to understand some of the things that happen in implementation, but again, it's not the focus of this course, and neither is maintenance. Maintenance would be things like DevOps, people that do help desk and and documentation and so forth. Again, we're going to talk about that a little bit in this course. We will cover that in one of the units of the course, but it's not the focus. The focus is the analysis and design, which you see on the bottom right-hand side of that diagram. So that's going to be the main focus, the analysis and design. So, if you think about it, it's the name of the course, right? This is the software development lifecycle or the systems development lifecycle, or in some cases, the systems analysis and design is another name for a course like this. Now, one of the traditional approaches to software development is the waterfall approach. And in the industry today, what the waterfall approach is almost said with a derogatory connotation because most people don't recommend this anymore. But basically, this is what the waterfall approach looks like. Notice what looks different about this approach from the previous diagram. Before, we saw planning, then analysis, design, and it was in a big circle and it cycled back to planning. But when you look at the waterfall approach, once we get from planning to analysis, design, implementation, then maintenance, notice what happens after maintenance. There's no arrow pointing back to planning. Thinking about a waterfall, once the water flows down a waterfall, does the water ever come back up? It does not. And that's the message they're trying to convey with the name of this cycle, of this traditional methodology, is that once you complete one of these phases, you never go back. So let's say you do some planning, you do some analysis, and then you start doing some design and you realize that the system is, maybe somebody realizes that, wait a minute, this isn't going to meet the needs of the users because there's a flaw in our analysis. There's no going back with this model. It's too late. You're already committed to that design. Now, this is more like what designing a car would look like, right? I keep talking about the process of designing a car. And this would be more similar to designing a car, where once we finish one portion of this, one part of this cycle, we don't go back, right? If we've already started tooling the factory and we've already started hiring people to work in that factory and training the people that work in the factory, we're not going to go back to that planning and analysis phase and start redesigning the car. Maybe little things we might go back, right? They might tweak something. Maybe instead of having leather for the steering wheel, maybe they're going to use plastic because the price of leather went up or something like that. But other than small things like that, we're not going to make any major changes at that point. Whereas with the model that we're going to concentrate on this course, we do have the ability, the flexibility to go back through that process as we learn as we're going through that cycle. So again, that's the waterfall approach. So some of the problems with the waterfall approach is feedback is ignored, milestones are lock-in design specs even when the conditions change over time. You have very limited user involvement. They're only in the requirements phase. After that, the users go away. We're designing something in a closet and hope for the best when we're done. And there's too much focus on milestone deadlines of the SDL phases to the detriment of sound development practices, which we'll talk about that. We'll come back to some of that throughout the course when I compare things sometimes to the waterfall model. So some of the other approaches and tools that we have, so we have case tools, agile methodologies, and extreme programming. Basically, case tools are computer-aided software engineering tools. So rather than us going through a formal process to do systems design, instead, we use tools that give us a graphical representation of a system that we're developing. The computer displays, prototypes of how the system's going to look and feel. And then it automatically checks for consistency in diagrams, forms, and reports. So it automatically makes sure that everything makes sense. And then it basically generates code for you. So it can generate standardized technical and user documentation. And I've seen some of these tools where you can actually output things like database code. And sometimes even business logic code can be automatically output by these different case tools. So case tools let you basically kind of bypass the SDLC in some sense because you're just doing things in this tool and then it's outputting the code for you. But you also lose a lot of control with case tools. You can only do what's possible in a case tool. You can't do anything outside that box. So that's certainly one of the major disadvantages of case tools. There was a time in IT when everyone thought that case tools were going to be the wave of the future, that we wouldn't even have software developers anymore because you'd be able to sit in front of a case tool and develop software without actually needing a software developer to do that for you. And a user would be able to develop their own system because they would have a case tool that would be able to translate what their needs are. And that's never happened. That idea never came to fruition. So we still need analysts, we still need developers, and case tools for the most part are just one more tool in the toolbox, but they certainly don't replace the SDLC. So another alternative to the SDLC that we're going to talk about in this course is Agile methodologies. And basically this was motivated by a need for software development to be fluid because of unpredictable and dynamic requirements over time. So there's three key principles to Agile. It's adaptive rather than predictive. It emphasizes people rather than roles, and it's a self-adaptive process. Now, what do we mean by adaptive rather than predictive? The SDLC is by its nature a predictive methodology, meaning that we try to predict what the needs are of our users. So before we start developing the system, we ask our users what their needs are, and we ask our users how they want it to work. And then based on what they tell us, based on what our analysis reveals, then we do the design, and then we code it, and we build it, or we buy it, or whatever it is we're going to do. But with things like the Agile methodologies, instead a developer might make some assumptions and make a very simple prototype and show it to the user. Then the user says, oh, this is pretty good, but let's move this over here, move that over there, and so forth. And then they go back and they make those changes and they just iterate through that very quickly. And the requirements are never formally codified, right? So we never formally declare what the requirements are. It's a very fluid process. If you do not like documentation, then Agile methodologies are perfect for you, right? So now Agile methodologies are also difficult in some ways. They're difficult for management. They're difficult on large projects. They're usually only effective on very small projects. But the Agile methodologies came from this manifesto for Agile software development, which I can't recall exactly who wrote this, although the names are down there at the bottom. But this was basically the idea of Agile software development. Now, the reality is, it's not that we don't use the Agile methodology in most of our projects. If you take a course like this, you may be expecting that Agile doesn't exist, but it really does. We do a lot of Agile in the field, and we have to be prepared for that. But a lot of times it's a hybrid, right? So we might be using the SDLC in an agile way, or using an agile technique, but incorporating the SDLC into that. Maybe incorporating some of the techniques for analysis and design. Maybe we do have to do some of the diagrams and models that we talk about in this course, because to make them reasonably understandable to the developers, because they don't know exactly what we're trying to do. So users could develop those diagrams and so forth, or an analyst might be working, within this group trying to do that. So it's not that we don't use Agile, it's just that it's typically used in conjunction with other techniques. And really, Agile is just all about, trying to be more nimble, trying to be more fluid in this process, being a little less stringent, as opposed to the SDLC, the more formal SDLC. And of course, the waterfall method would never be able to implement any of this Agile stuff. Because waterfall is just way too structured to support something like this. All right, so when to use Agile methodologies. If it's unpredictable or has dynamic requirements, if you have very responsible and motivated developers that do not need instructions on what to do, right? You don't have to lay out exactly what needs to be done day to day. They're motivated and they're willing to do the work without being told what to do, for example. And if you have the customers who understand the process and they are willing to get involved. So a lot of customers don't have the time to get so involved in the development. The Agile process, you're really involving that customer every single day. They're coming back to have to look at it, and they're going back and forth. So if you're doing a formal development of some system for someone, you may not have the option to do Agile because of that reason. But in some cases, your customer might be much more involved, and you can utilize the Agile methodology. So typically it's small projects for Agile, which I think I mentioned before, usually very few people working on the project. You just have a very small team of developers. And the traditional methods work better on the larger projects with lots of developers, and where you have a predictable requirement. You can do that analysis adequately enough for the traditional methods. So extreme programming is another example. This is where you do short incremental development cycles with automated tests. They're typically done with two-person programming teams that are doing coding testing. They're listening and designing. They're working together very closely. They code and test together and so forth. So some of the advantages are the communication between the developers is much faster and easier when you have a good team or a good group. A high level of productivity. They can work very quickly together and generally can produce pretty high quality code. But again, this only works in small projects or smaller groups or smaller teams, so it is somewhat limited in that sense. Now in this course, I am going to talk about, and we are going to use the object-oriented analysis and design technique. So we're going to learn a lot about this, and the reason that we're going to cover object-oriented analysis and design is because this has really become the state of the art today. So you can see in my presentation, I have UML highlighted on the left-hand side. Basically, and I'll talk about that in just a second, but basically object-oriented is a software development methodology where we are treating things as objects. So we're structuring things as objects that have behaviors, and that's an important part of object-oriented programming. And objects have a class, in other words, a classification that describes that object, and I'll talk about this in more detail later in the course. And those objects can inherit things from other objects. And again, we'll talk about inheritance and how all that stuff works. But why is that important here? We are going to use UML, which is the Unified Modeling Language. And I'll explain what UML basically is. UML is a standard for creating designs and models for software analysis and design and systems analysis and design. It's a standard way of showing the workflows, the activities, what systems need to do. And in this course, I'm going to show you, there's one method that we talk about in this course called Gain and Sarson, which is the data flow diagramming technique. There's also a technique called ER diagramming, which is typically used by database designers and so forth. And we'll talk about that. However, with all of that said, the Unified Modeling Language is probably far more common than the other ones we're going to talk about in this course. Now, the first two are great because they help you understand how to think like a software developer, think like an analyst. You're trying to decompose systems. You're trying to understand what the requirements are, understand what the steps are to complete a process. try to formally think about all of the different parts and pieces and how they come together. And you can make these diagrams, these data flow diagrams, but in my experience, if you go to a software development shop, an IT shop, a business that has an IT department of a moderate size, they're not really going to be using data flow diagramming. This is an older technique that's been largely replaced by unified modeling language. So unified modeling language is sort of, if you think about an architect, I'll go back to the example of an architect. Architects, when they draw these pictures of how to build a house, there are common elements that they draw that have a syntactical element. In other words, there's a syntax to drawing where a lamp is going to go, or where an outlet's going to go, or how a plumbing fixture is going to be installed, or what type of plumbing fixture it is. They don't literally draw a picture of a toilet. They draw symbols that show here's where a toilet's going to go, here's where the sink is going to go. This is the hot water line, the cold water line. You know, all of these different things that we have to draw in a blueprint. They're not literally drawn. There's a syntax that everyone in the field, all the tradespeople, all the people that look at those diagrams are going to understand what all these things mean, and it gives it a much more powerful meaning behind that drawing when everyone understands exactly what everything is in that drawing. And we're going to learn that technique in this class. We're going to learn the techniques that we use and we learn them for a number of reasons. Number one, it's great to understand these techniques because you can use them. There's lots of things. You know, these techniques are not just used for software development and systems development. You can use them to analyze business processes, to analyze workflows, you know, to help make sense of things and decompose, you know, activities and things like that. So lots of great reasons to use UML even outside the SDLC. But the other purpose of this is, even if you're not going to be a systems analyst, it's a really good idea to understand how to read and how to interpret the UML standard or the UML developed diagrams and models so that you'll fully understand what's being described for a system. Somebody might say, here's how the system is going to work, or here's how we design the system, and they show you a diagram. It's no different than, you know, an architect showing me a blueprint, and if I don't know how to read a blueprint, then I'm not really going to understand what I'm looking at. I'm not going to be able to evaluate the design that the architect made for me if I don't know how to read blueprints. Likewise, we can't evaluate the designs of systems if we can't understand what we're looking at, if we don't know that syntax. So it's important for us to learn that and to understand that. So systems development, the object-oriented software analysis and design process is officially in the UML standard. So UML is actually a standard. You could buy a textbook that by Fowler, I think it is, that describes the UML standard that came out in 1997. I think UML 2.0 came out later in the early 2000s, but they use different terms to describe some of the same things we talk about in the SDLC. But again, in the real world, we've kind of merged these together a little bit. No one really is, you know, doesn't seem like we see a pure object-oriented systems lifecycle, and we don't see really a pure structured base. So structured base is where we lack those object-oriented attributes, and we don't use UML. But we don't really see systems that use a pure methodology in that area as well. A lot of times we're taking bits and pieces from all these different methodologies to do something that works, and that's really going to be the focus on this course. Is we're going to look at we're going to take some of the elements in all of these different methodologies and techniques, you know, all the ones that are common in practice today, and we're going to learn about all of them and how they're frequently implemented in some of the best parts of these different methodologies, tools, and techniques. So some of the criticisms of learning a formal process that some people will bring up is forcing timed phases on intangible processes, make it doomed to fail. In other words, some people say that SDLC and learning these processes, you'll never use them because there's too much structure. Some people will say that. Some people say it's too much formality. Documentation slows everything down. Developers sometimes don't like to do documentation. IT people sometimes don't like to do documentation. People criticize the cycles and so forth, which are not necessarily waterfalls. But yet, even with all of these criticisms of SDLC, the concept of a cycle and the concept of SDLC is a valuable model, as I discussed before. We're going to talk about, again, different ways to implement these, and it's ubiquitously used throughout the industry, so it's important for us to understand the formal process of SDLC as well as some of the other methodologies, techniques, and approaches for software systems development. So in this slide deck, we talked about defining an information systems. where we talked about the SDLC, the life cycle, the different parts like planning, analysis, design, implementation and maintenance, and the iterative nature of it. I talked about some case tools in this video, as well as extreme programming and agile methodologies. And then I ended this with talking about object-oriented analysis design and the Unified Modeling Language, or UML, which we're going to learn in this course as well, in addition to things like GAIN and SARSIN and ER modeling, which are also important.